How 3D game rendering works, texturing. Bilinear, trilinear, anisotropic filtering and more. What does it mean? In this third part of our deeper look at 3D game rendering, we'll be focusing what can happen to the 3D world after the vertex processing has done and the scene has been rasterized. Texturing is one of the most important stages in rendering, even though all that is happening is the colors of a two-dimensional grid of colored blocks are calculated and changed. The majority of the visual effects seen in games today are down to the clever use of textures. Without them, games would dull and lifeless. So let's dive in and see how this all works. As always, if you're not quite ready for a deep dive into texturing, don't panic, you can get started with our 3D game rendering 101. But once you're past the basics, do read on for our next look at the world of 3D graphics. Part 0, 3D game rendering 101. The making of graphics explained. Part 1, how 3D game rendering works, vertex processing. A deeper dive into the world of 3D graphics. Part 2, how 3D game rendering works, rasterization and ray tracing. From 3D to flat 2D, POV and lighting. Part 3, how 3D game rendering works, texturing. Bilinear, trilinear, anisotropic filtering, bump mapping, and more. Let's start simple. Pick any top-selling 3D game from the past 12 months and they will all share one thing in common, the use of texture maps, or just textures. This is such a common term that most people will conjure the same image when thinking about textures, a simple, flat square or rectangle that contains a picture of a surface, grass, stone, metal, clothing, a face, etc. But when used in multiple layers and woven together using complex arithmetic, the use of these basic pictures in a 3D scene can produce stunningly realistic images. To see how this is possible, let's start by skipping them all together and seeing what objects in a 3D world can look like without them. As we have seen in previous articles, the 3D world is made up of vertices, simple shapes that get moved and then colored in. These are then used to make primitives, which in turn are squashed into a 2D grid of pixels. Since we're not going to use textures, we need to color in those pixels. One method that can be used, called flat shading, involves taking the color of the first vertex of the primitive, and then using that color for all of the pixels that get covered by the shape in the raster. It looks something like this. This is obviously not a realistic teapot, not least because the surface color is all wrong. The colors jump from one level to another, there is no smooth transition. One solution to this problem could be to use something called Gouraud shading. This is a process which takes the colors of the vertices and then calculates how the color change. For more on this story, visit the news article link.